More than 4 decades after launch, Voyager 2 has officially crossed the edge of our solar system, entering interstellar space. A spacecraft built in the 1970s is now exploring a place no human has ever reached before. Even more astonishing, it is still communicating with Earth from over 20 billion kilometers away. Think about that for a moment. Every command sent to Voyager 2 travels at the speed of light, yet it still takes nearly 19 hours to reach the spacecraft. Then another 19 hours for its response to arrive back on Earth. A simple conversation with Voyager takes almost 38 hours. And somehow, despite the unimaginable distance, this tiny spacecraft keeps talking. By the end of this video, you'll understand how Voyager 2 survived for nearly 50 years in deep space, what scientists discovered beyond the solar system, and why this mission may continue long after humanity itself has changed forever. But first, we have to go back to 1977. The 1970s were the height of the space race. NASA had already landed astronauts on the moon, but scientists wanted something even more ambitious. They wanted to visit every giant planet in one mission. Normally, such a journey would require centuries because each planet orbits the Sun at different speeds. But astronomers noticed something extraordinary. Once every 176 years, Jupiter, Saturn, Uranus, and Neptune line up in a rare planetary alignment. It was a once-in-a-lifetime opportunity. By carefully using each planet's gravity as a giant slingshot, a spacecraft could visit all 4 worlds without carrying enormous amounts of fuel. NASA realized that if they missed this alignment, nobody alive would see another chance. So they built 2 spacecraft, Voyager 1 and Voyager 2. Although Voyager 2 was launched first on August 20, 1977, Voyager 1 followed 16 days later on a faster trajectory designed to reach Jupiter first. No one expected these spacecraft to still be operating nearly half a century later. Their planned mission was only 5 years. Instead, they became the greatest exploration mission in human history. Voyager 2 was unlike anything NASA had ever built. It carried powerful cameras, scientific instruments, plasma detectors, cosmic ray sensors, magnetometers, and a large radio antenna nearly 4 meters wide. But perhaps its most famous feature wasn't scientific at all. Attached to its side was a golden record. Created under the leadership of astronomer Carl Sagan, this gold-plated copper disc contained sounds and images representing life on Earth. There were greetings in 55 languages, the laughter of children, the sound of rain, whale songs, classical music by Beethoven and Bach, traditional music from cultures around the world, even instructions showing an alien civilization how to play the record. It wasn't meant for today's scientists. It was a message for anyone, or anything, that might discover Voyager millions of years from now. A time capsule drifting forever through the galaxy. Then came the first great destination, Jupiter. In July 1979, Voyager 2 flew past the solar system's largest planet. Scientists expected incredible images. What they got completely changed planetary science. Voyager discovered active volcanoes on Io, one of Jupiter's moons. Not ancient volcanoes. Living volcanoes erupting before humanity's eyes. It was the first time active volcanism had ever been observed beyond Earth. The spacecraft also revealed hidden structures inside Jupiter's atmosphere, measured its enormous magnetic field, and captured breathtaking close-up images of the Great Red Spot. Every day seemed to rewrite another science textbook. But Jupiter was only the beginning. In August 1981, Voyager 2 reached Saturn. Its cameras revealed stunning details inside Saturn's rings. Scientists discovered thousands of delicate ring structures that no telescope from Earth had ever seen. The spacecraft also examined Saturn's largest moon, Titan. Although thick clouds hid the surface, Voyager confirmed Titan possessed a dense atmosphere, something incredibly rare for a moon. Years later, this discovery would inspire NASA's Cassini mission, which eventually landed the Huygens probe on Titan itself. Voyager wasn't just exploring planets. It was laying the foundation for future exploration. Then came the mission that made Voyager 2 truly unique. Unlike Voyager 1, which turned upward after Saturn, Voyager 2 continued deeper into the unknown. Its next destinations had never been visited by any spacecraft. Not once. Not ever. Ahead lay Uranus. a frozen blue world nearly 3 billion kilometers from the Sun. And beyond that, Neptune, the most distant major planet in our solar system. Few believed a spacecraft launched in 1977 would ever reach them. Yet Voyager 2 kept flying. When Voyager 2 officially crossed the boundary of the heliosphere, humanity entered a completely new chapter of exploration. For the first time, a spacecraft built by humans was no longer traveling through the Sun's protective bubble. It had entered the vast and mysterious region known as interstellar space. But what exactly does that mean? Many people imagine interstellar space as empty darkness. In reality, it is anything but empty. Between the stars lies an incredibly thin mixture of gas, dust, magnetic fields, and high-energy particles. It may seem almost like a vacuum, but over distances measured in trillions of kilometers, these tiny particles become part of an enormous cosmic environment that shapes our entire galaxy. As Voyager 2 crossed the heliopause, its instruments immediately detected something remarkable. The number of charged particles coming from the Sun dropped dramatically. At the same time, particles arriving from outside our solar system suddenly increased. It was the clearest proof yet that the spacecraft had left the Sun's influence behind. Even more surprising was the change in magnetic fields. Scientists expected the magnetic field beyond the heliopause to point in a completely different direction. Instead, Voyager 2 found that the interstellar magnetic field was almost perfectly aligned with the one inside the heliosphere. That unexpected discovery challenged decades of scientific theories and forced researchers to rethink how our solar system interacts with the rest of the Milky Way. Another mystery soon appeared. Voyager 2 measured the temperature of the plasma surrounding the heliosphere and discovered it was far hotter than expected, reaching tens of thousands of degrees. That sounds impossibly hot. Yet if a human somehow stood there, they wouldn't actually feel warm. Why? Because the particles are so incredibly spread out that almost none would ever touch your body. Technically, the temperature is extremely high, but the density is so low that almost no heat can be transferred. It's one of the strangest places in the universe, a region that's both freezing and incredibly hot at the same time. These discoveries are only possible because Voyager 2 carries instruments that continue collecting data every single day, despite being more than 20 billion kilometers from Earth. The spacecraft sends its information using a radio transmitter weaker than a household light bulb. By the time that signal reaches Earth, it has traveled for nearly 19 hours, racing through space at the speed of light. When NASA's Deep Space Network receives it, the signal is unbelievably faint. In fact, engineers often compare detecting Voyager's transmission to hearing the sound of a single raindrop falling on the ground from thousands of kilometers away. Yet somehow, they still manage to hear it. Every tiny packet of data is precious. Every measurement reveals something no spacecraft has ever observed before. And Voyager 2 keeps sending those discoveries back to Earth, one whisper at a time. But the spacecraft itself is slowly running out of power. Its electricity comes from a radioisotope thermoelectric generator powered by plutonium-238. Unlike solar panels, which would be useless this far from the Sun, the generator converts heat released by radioactive decay into electricity. The system has worked continuously since 1977. However, every year it produces slightly less power. To keep Voyager alive, NASA engineers have been forced to make difficult decisions. One by one, scientific instruments have been turned off forever. Heating systems have been disabled. Backup equipment has been shut down. Every watt saved means a few more months, or perhaps another year, of exploration. It's a constant battle against time. And yet, nearly 50 years after launch, Voyager 2 is still doing exactly what it was built to do. It keeps exploring the unknown, farther from Earth than almost any human-made object has ever traveled.